Okay, welcome back to another moment of joyous learning. And today we're going to continue with function composition. So we're going to talk about the of operation, right, that we started working with in the previous lesson, right, in lesson 3. And so today we're going to talk about creating new functions by finding a composition of existing functions. So kind of what we did yesterday. However, what we're going to do today is we're actually going to do this with generic functions. We're not going to do this with values of functions. We're going to do this with the actual function itself, right? So, so the math is going to be just slightly more abstract, but it's the same exact concept. So if you can just apply that to it and use what you know about multiplying and adding and subtracting polynomials, you'll be in good shape. All right. So let's just dive right in. So we're going to create new functions. And talk about composition of functions, right? The concept review and composing functions, all right? And so here's the concept review. When you compose functions, right, it means you're putting one function into another function, right? That's the classical terminology of composition of functions, right? And so here's a picture where you put something into one function, right? Something comes out, and then you take that and you put that result back into a different function, and you get that result. So what they do is they come up with a name for that whole process, right? And so that name is, in here is, they write it as f of g of x. The other way that we've been using more is f of g of x, right? So it looks like fog. I should make this a little smaller. And what this means of, right, f of g of x, right? So it's not a multiplier, right? It just means f. The multiplier will be filled in. And so these are the two different ways you'll see it, right? And in yesterday's lessons, we kind of talked about how to deal with this when you have values for x, right? And you know f of x and you know g of x. And so the overarching concept is working backwards, right? You start with g of x and then you plug whatever your value for g of x is into f of x, right? And so with that, it says we can find compositions of functions at particular values, and we can find compositions of whole functions. So this is what we're going to talk about today. So in other words, with no values, right? So we're not putting values in. We're using, you know, another way of saying it is kind of the generic or general case, right? So the general case is when you just leave the variables as the variables and plug it in, and you can do that, and it works pretty well. All right, so let's just jump in, okay? So this first one, we've got two functions. We've got 2x minus 5, that's your f, and we've got gx equals 4x, and it says find the following compositions. So it's f of g of x, and so what we know is we know that we work backwards, right? We work backwards. So we're going to start with g of x. So we got to find g of x. Now what's great about these is your starting process is super easy because we know g of x. G of x is 4x. So we're already halfway done. Now what we do is, because this is a general case and we don't have a value to put in, we're going to take that, we're going to take 4x, and we're going to put it into f of x, right? So you've got f of x, and I'm going to write this a specific way, right? And I'm also going to write this 4x in red, okay? And then we're going to go back to black for this. Okay, and so so f of x is 2x minus 5, right? Now, if we're going to write f of g of x, all right, we're going to write this. What we're going to do is we're going to write 2, and then we're going to put a parentheses wherever we have an x. And we're going to leave it open and then finish writing our function. Okay, and so now what I'm going to do is I'm going to take g of x and I'm going to insert that wherever x is in this. So that's kind of what we did before, right? You take this, you plug this value into whatever x is in the second function. Well, the value is 4x. It's not 4, it's 4x, right? So we're going to take 4x and we're going to put that right here. So we're substituting 4x in for x. And it's a little confusing because it's the same variable, but, you know, we're good mathematicians. We can handle that. All right, and so now all you got to do is just, usually there's going to be a multiplying step and then adding and subtracting, some combining like terms possibly. All right, so let's multiply this. So you get 2 times 4x is 8x. And then it's 8x minus 5, right? Because you're only multiplying this 2 times this. In this case, there's nothing else to do, right? There's no, there's just nothing else to do, right? There's no combining of like terms because you have an x term and you have a constant. All right, so this is my composed function. The other way you could write it is like this, f of g of x, right? So you're taking g of x and you're inserting it into f of x wherever you see x, right? So that's what we did. We took that 4x and we pumped it in there where x is. And yeah, and that's it, right? And so it's probably easy, if you do these in your head, you might think, oh, I'm going to put 4x in there and multiply them, right? 4x times 2x. But the thing is, you're not just doing a straight multiplication thing. You have to put this in place of x. So this x goes away, is replaced by an opening slot for that new function. You put that in, and then you do the work, right? So that's the big thing you got to remember with this. All right, so let's try going the other direction now, okay? So if we have g of f of x, right, you're going to start with f of x, all right? We're going to start with this, okay? And my f of x is already figured out. It's 2x minus 5, right? I know what f of x is. It's this, all right? Now we're going to take that and we're going to put it into g of x. Well, g of x is 4 of x, right? 4 times x. So now what we're going to do is we're going to take this and we're going to put it in place of 4x, right? So we're going to go 4 times, and then where you see x, we're going to put parentheses. We're going to make them a little bigger because we got to fit this whole thing in here. You know, 2x minus 5, right? And then all we do is just multiply. 4 times 2x is 8x, and then 4 times negative 5 is negative 20. And so your g of f of x, right, is 8x minus 20. So I think once you can get used to kind of the concept of you're getting in your second function that you're dealing with, you're basically dropping the variables and replacing them with a spot to put the first function. And you got to do that in each spot that you have it. And we'll look at some harder ones where you have to do more of that, right? Where you're putting it in more than once, okay? So, but this is the general concept. This is the idea, right? So hopefully this is sort of making sense. So come back for the next video and we'll do some slightly harder problems.